So on one single day, you put the cleaners bottles with near the bread, then near beer, and on the third day near cleaners, and you obtain the data. Now the question is that at 0.05 significance level, is there a difference in the mean number of bottles sold at three locations? Is there a difference in the mean number of bottles? Also, definitely you can find out the mean number of bottles that were sold when they were near bread, when they were near beer, when they were near cleaners. So there are three populations basically, and you are interested in knowing that on average, is there any difference between the sales of the bottles when you put or place the bottles at different locations? So this is the question. So I think now the meeting is being recorded. Is it? Yes, it is being
Yes, sir.
recorded. Okay, so I think if it is being recorded, then I shall start it again because it is for the benefit of the students. So today we faced several issues in recording the lecture. And as there are so many students who are unable to join the class at the right time because of internet issues, so it is very important to record the lecture. So unfortunately, we tried several times and we remained unable to record the lecture. But fortunately, at this time, it has automatically been started. So let me start again the
सर
lecture.
मैंने स्टार्ट की है.
Khizar Nadeem. Okay, so if you have started this, so thank you very much. And now I have to, I would like to repeat a few things that I've just explained for the benefit of the other students who are not there in the class. So basically, we had started chapter 12 of your book, and we solved few examples where we saw that the variances of the two populations were equal or not. And for that, we simply use the formula. In the previous class, you can see my notes. I used this formula. And I used this formula for two situations. One was this, where I set the hypothesis, null hypothesis like this. And the other situation was where I solved one question where I set the null hypothesis as this. And you know the details and how I set the null and alternate hypothesis. So you are familiar with this concept, but the issue is that I used F statistic in this case. And similarly, today I'm interested in explaining the concept of F statistic and basically the use of F statistic. And you know, we can also use F statistic when there are three or more populations are involved in some situation. So let us see this question that is self-review in your book 12-2. So there is a citrus clean in a new all-purpose cleaner being test marketed by placing displays in three different locations within various supermarkets. So there are various supermarkets where they are going to place the citrus clean, that is a cleaner. Okay, so they want to check basically that at which place it would be better to uh, place the cleaner. So in different markets, so in one supermarket it was placed near bread, you can say in bread section, and in some other supermarket near beer, and in some other supermarket near the other cleaners. So this may be one scenario, or the other scenario you can establish yourself. You may consider the situation. Let's say you are in the metro shopping mall, and on one day you place the cleaners near the bread, on some other day you place the cleaners near the beer, and some other day you place the cleaner, I mean citrus clean, near the other cleaners, so in cleaners section, I mean. So in this way you see that how many cleaners bottles are being sold. So let's say on the on this particular day, when you place the cleaner near the bread, so these are the quantities. So 18 sold, 14 sold, 19 sold, 70. So let's say for 4 days data you are going to collect. So on first day 18, on second day 14, on third day 19, on fourth day 17 bottles were sold when they were placed near the bread. Similarly, on some other day, this was the situation. So 4 days sales are there. Similarly, on some other 4 days, the sales data are there. So 32 means 32 bottles were sold on some particular day, on fourth day, let's say. So this is the situation, and you are interested in knowing that at point zero 0.05 significance level, is there a difference in the mean number of bottles sold at the three locations? So mean number of bottles means you can see, you can add these numbers and divide by 4. So you would have the mean. So mean number of bottles when sold when they were near the bread. Similarly, mean number of bottles sold when they were near the beer. Similarly, when they were near the other cleaners. On average, how many bottles were sold? So you can find out the average number or mean. So you have to check that is there a difference in the mean number of bottles or not. So first of all, if these questions are not there, you can solve it using the 6 steps. But as the questions are there in form of parts, so we shall try to answer these questions one by one. So first of all, state the null hypothesis and the alternate hypothesis. So how will you write down these two hypotheses? First of all, you will write down, let me write down here. Step 1, null and alternate hypothesis. And in this case, first of all, you will write down null and alternate hypothesis. That I'm not going to write down. I'm simply writing down the hypothesis in form of notations. So mu, mu, and mu. So why I'm writing down mu, because I'm interested in considering the mean number of bottles sold at 3 locations. So mean number of bottles, regularly these are the sample data values, and I am interested in population data values. So population mean is denoted by mu, so therefore I'm writing down mu. So whatever is true for sample, I want to confirm that for the population. Whatever is true in case of sample, that is true in case of population or not. So this is the scenario, and you can write down mu, 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 and then again in case of H1, you can also write down, there may be two ways to write down these. One is that, first of all, you have to see that how many samples are there, or how many populations, how many samples are there from definitely populations. So there were 3 populations, so there are 3 samples, 1, 2, 3. So now near bread, near beer, and with cleaners. So you may write down 1, mu1 is near bread, mu2 is near beer, and mu3 is near other cleaners. So equality sign is there, means all means are equal. Similarly, in the alternate hypothesis, you may write down that they are not equal. Fine. And you can also write down this alternate hypothesis as, you can also write down, instead of writing this, you may write down H1 as all means are not equal. Not equal. Okay, or you may write down at least one mean is not equal to other, or you may write down at least 2 means are not equal. So in that case, I mean, the situation will be this, that this will be the null hypothesis. If, let's say, if 2 are not equal, so the null hypothesis would be rejected. Okay, so you first have to write down this, and answering this I have written, state the null hypothesis and the alternate hypothesis. So in null hypothesis, means are equal, in alternate hypothesis they are not equal. What is the decision rule? What is the decision rule? So how will you write down the decision rule? Definitely you will draw the F distribution, and you will see that what will be the critical value of F in this case. This is the F scale. Relative frequency is there, or probability is there on the vertical axis. Okay, so you have to see that what will be the f value at this point and also at this point. But let us see that what will be the f value. There is no need of drawing this distribution over here, because you see, uh, there are three populations. Okay, so when there are, you can say the case is regarding the sigma 1 square, sigma 2 square, then you may draw this. Otherwise, if you simply use the tabulated value of f and the calculated value of f to decide something regarding the null hypothesis, that is sufficient. Okay, so it's upon you, you may draw it or you may not draw it. Okay, so the question is, how will you find out the tabulated value of f? So you will see that what is the level of significance. Level of significance is, in this case, if you see, it is 0.05 given, and you have to write down the degrees of freedom. What will be the degree of freedom in this case? So for that, you have to see that how many treatments are there, how many treatments are there. So I am calling these as treatments. So one treatment, second treatment, third treatment. So there are three treatments. There are three treatments. So treatments may be denoted by K. Treatments may be denoted by K. So there are K treatments, let's say. So K minus 1 will be the degree of freedom. So I may represent it with, for your convenience, new 1, new 2. So because you are familiar with this new 1 and new 2. So what will be new 1? New 1 will be, definitely this is the degree of freedom. And in this case, you will subtract 1 from the number of treatments. 1 from the number of treatments. So number of treatments in this particular case is 3. So 3 minus 1, this is 2. 3 minus 1, this is 2. And new 2, what is new 2? New 2 is again a degree of freedom, and this degree of freedom is for denominator. So new 1 is the degree of freedom for numerator, and new 2 is the degree of freedom in case of denominator. So for this, you have to subtract k from n. K from n. N is the total number of observations. So if you see how many total numbers are there, how many total observations are there in this table. So you can see 1, 2, 3, 4, 4 and 4. So 12. 12 observations are there in total. So n is equal to 12 minus k. K number of treatments, they are 3. So the answer is 9. So now you can see that what will be the critical value when f is 0.05. New 1 is 2 and new 2 is 9. So this will be the critical value. Okay, and you can see this value from the table. If you come over here, tables are there, and you have to move to the relevant table, 2 and 9. So this is 2. Let me see, degree of freedom for numerator, this is 2, and for denominator it is 9. So you have to see this table. Degree of freedom for numerator is 2 and degree of freedom for numerator is 9. Okay, so this is the relevant table, and here you have to see the level of significance, that is 0.05. So this level of significance. So from here you have to move to the rightward, and you can see that 4.26 is the value, and this is the critical value. This is the critical value. So you have to write down this 4.26 over here, 4.26. And here in the senior rule, you may write down that if the computed or calculated value of F statistic that definitely you will find out using the formula will exceed this value, then we would reject H naught. Otherwise, if it is not greater than this value, the calculated value will be less than this value, then that value will be in this section, anywhere from this point up to this point, then you would remain unable to reject the null hypothesis. And if you are interested in knowing the lower side, then you simply can take the reciprocal of this value. So these will be the two limits. Okay. So let us see what happens finally. So compute the values of SST, total sum of squares, and this is the sum of squares for treatments, sum of square error, or error sum of square. So these are the terms that you have to use over here when you are interested in finding out the calculated value of F. Okay. So there are two strategies. There are two strategies to find out these values. First of all, see what are these values. There is some other example is solved over here, but I am interested in explaining this is one strategy. No applications are there, so leave it. Calculate total sum of squares. We can write it down as TSS. One thing is TSS. TSS means total sum of squares. Total sum of squares means total variation in the data. Total variation in the data. So this is equal to, you can write it down as total variation in the data is equal to, normally in econometrics we use regression sum of squares. And if you see in your book, it is SST and error sum of square. Okay. So what is this RSS? Don't consider regression at the moment. Simply consider it as sum of squares for treatments. So I mean the variation in the treatments. What this means? SST, it is there. SST in your book, you can see SST in your book. I am writing it down as RSS. You can consider it as SST or RSS. Basically, the idea is this, that what is the variation between the treatments. You can also write it down as BSS, variation between the treatments. Fine. So it's upon you. Your book is writing it down as SST. Okay. And for error sum of square, the notation is there as SSE. So I'm writing down as ESS, error sum of square. Similarly, total sum of square. So total sum of square means the total variation in the data. And RSS means sum of squares in treatments, means variation in the treatments. Okay. So let us calculate this. There are basically two ways to calculate these values. Okay, the one way is this: if you are interested in finding out TSS, so out of these three, if you are able to find out ESS and TSS, this is the strategy that is there in your book. TSS and ESS, these two, if you are able to find out these two, the third one could be found out straightforwardly, because you can transform this equation, you can solve this equation for RSS to find out the value for RSS. Okay, if you are able to find out TSS and ESS. So let us see how we can find out TSS and ESS. TSS, total sum of squares. For this, you have to write down uh, values that are there. Let's say x minus xg bar. So what is this? X are the values that are there in the question, in the data values. These are the data values. And what is this? G. G is the grand mean. Grand mean means you have to add all these values that are there in this question. Add all these values and divide by 1, 2, 3, 4. 4 multiplied by 3, 12. So divide by 12. So you will have the grand mean. Okay. So one by one, you have to write it down. How will you write it down? Let's say if you see it was 18, 14, 19. So, and you will open this. How will you write it down? First of all, you will find out the average. So 18 plus 14, what are the values? So for that, I have to, let me open the book. So you must have book with you, because I can't do this again and again. I can't move my cursor above and down. So better would be if you have your book with you. So yes, these are the values. So 18 plus 14 plus so on up to the last value is 32. Okay, and you have to divide it with 12. So if you have calculator with you, you can find out the answer by adding these values. Let's see what is the average. See what is the average value. Don't you have calculator with you?
Sir, calculator
सर
तो
बुक
है
से सारी
पर
वैल्यूज देखनी।
Sorry?
वैल्यू
सर वो वैल्यूज नहीं है हमारे पास, वो बुक से देखनी पड़ेंगे सारे ओपन करके।
Okay, so see, the answer is 20. The answer is 20. This is the average. When you will add all these values and when you will divide it with 12, you will have 20 as your answer. Fine. So, and see, there is scare on this. Sum of scare deviations. Okay. So scare is there. So now, first of all, you have found xg, grand mean or grand average. Then what will you do? TSS, you will write down over here TSS, and summation sign is there. This is summation sign. It means that all terms will be added. So first term will be, let me see the data again. The first term will be 18, yes. So you will write down here 18 minus 20 square plus, then second number was 14 minus 20 square plus so on. Similarly, you will move up to last term, and that is 32. So 32 minus 20 whole square. So in this way, when you will solve it and add all these terms, finally you will have the value for TSS, and that value is, in this particular case, is 578. It is 578. So this is the total variation. This is the total variation in the data. Okay. Then the question is, what is the error sum of square? What is the error sum of square? So we also call this error sum of square as within sum of square. Within sum of square or error sum of square. So for that, what will you do? ESS. So ESS is equal to, the formula for this is simply x minus, you can see in your book it is xc square, like this. But the idea is this, that you have to subtract the average that you will find out from the relevant column. Let's say from this column, from first treatment, you will find out the average, the concerned average. Okay, you may consider C as concerned average. So concerned for first column, concerned average for second, concerned for third. So what is the average in this case? What is the average in this case? What is the average in this case? So that average will be subtracted from the concerned values. Let's say 18 minus whatever average you will find out using these four values. Then 14 minus that average, 19 minus that average, 17 minus that average. Similarly, when you will take into your account the second column, you have to find out the average that is for these four values, and then you will subtract that average from these values one by one. Similarly, in this case. So what will be the average in this case? Let's say in first column, the average is I have found 17. So you will write down the first value, let's say 18. 18 minus 17. 18 minus 17 square. 18 minus 17 square plus second value. Second value was 14 minus 17 square plus so on. And I'm going to write down the third value is there, and finally the fourth value is there. That is 17 minus 17 whole square. Then plus, then you have to consider the second column. So you have to add these values: 12 plus 18 plus 10 plus 16 divided by 4. See what is the answer. Add these values.
Sir, दूसरे column का mean 14.
Add these values: 12 plus 18 plus 10 plus 16 divided by 4.
Sir, 14.
14. Okay, so you have to subtract 14 from these values one by one. So the first value in this column is 12. So 12 minus 14 square plus second value was 18. 18 minus 14 square plus third value, or so on, plus the final value is 16. So 16 minus 14 whole square. Then plus, now you have to consider the third column. The third column is starting from 26. So 26 minus, in this case, what is the average? The average is
29.
29. So 29 square plus so on up to the last term, and last term was 32. So 32 minus 29. So you can see in this case, when I was interested in finding out the total variation, then I simply subtracted 20 from all the values. Okay, and in this case, when I was interested in error sum of square or within sum of square, then I subtracted the concerned average from each value of some particular column. Okay, so when you will solve this, the answer that you will obtain will be 74. I have solved it. 74. Fine. So now you have these two values, TSS and ESS. So you are able to find out RSS, or we also call it between sum of square. Okay. So this is within sum of square. You can write it down as WSS, and you can write it down as BSS, between sum of square. And in econometrics, you will see that it is regression sum of square. So here you can write out, you can find out RSS as RSS is equal to TSS minus ESS in this way. So 578, this was the total variation, and this is the value of 74 is your error sum of square. Okay, variation within treatments. So the answer is 504. 504. So we have answered this part, and we have provided the values for SS total, SST, and SSE. Now develop an ANOVA table. This is very important. How will you develop an ANOVA table? In an ANOVA table, you can see the format of the ANOVA table is like this. Here, first of all, we write down source of variation, SOV, source of variation, or you can completely write it down as source of variation. So source of variations, the first source of variation is regression sum of square, or as I have used regression sum of square, basically RSS is regression sum of square, but in this case we are taking it as treatments sum of square. So you can write it down as SST or RSS, no problem. And then within sum of square, or you can also write it down as error sum of square. And finally, total sum of square. So these three you have to write it down over here. So basically, if you see the second column is for degree of freedom. Okay. And the third column is for sum of squares. So that is SS. You can write it down as sum of squares. So if you are going to write down it as sum of squares, so there's no need of writing RSS over here. So here, let me complete it first, then I will rub it. So then comes mean square, MS. Okay. And finally, you have a column for F. Finally, you have a column for F, and in this column, you will have the calculated value of F statistic. So for to find out the calculated value of F statistic, these are the prerequisites. You can say that except these values, we are unable to find out the calculated value of F. So here you can write down, in case of source of variation, you can write down over here in the first step, here you can write down treatments, okay. Then here in the next row, you can write down error, okay, and finally you can write down total. So both are the ways. So you can write down RSS, ESS, or TSS, or you can write down treatments, error, and total. So treatment means in first case you have to see that how many treatments are there. So basically there are 3 treatments. So degree of freedom will be K minus 1. K minus 1 means number of treatments minus 1. So that is 3 minus 1, answer is 2. Okay. Error, what will be the degree of freedom for in case of error? It will be N minus K. So N is 12, 12 minus K means 9. 12 minus 9 means is equal to 3. 12 minus 9 is equal to 3. And what is the total? In case of this, degree of freedom will be N minus 1. So N minus 1 is, N is 12, 12 minus 1 is 11. Okay. So now you can see, sorry, this is 3. No, sorry, this is number of treatments. Number of treatments are 3. So 12 minus 3 is equal to 9. Okay. So now you can see 2 plus 9 is equal to 11. 2 plus 9 is equal to 11. Or if you write down the degree of freedom for treatments, and you know N minus 1 is the degree of freedom in case of total observations. So 11 minus 2 is equal to 9. Okay. So you can add these two to have this, or you can subtract 2 from 11 to have 9. Okay. Then there comes SS. So in your book, it is written as SST. I am writing it as RSS. So what is the value for this? I have found. RSS is equal to 578. So that 578 will be written over here. Similarly, what is ESS? So ESS was 74. I have calculated over here 74. Okay. And then what is MS? Mean square. So for mean square, you have to divide this value with its degree of freedom. So 578 divided by 2. 578 divided by 2. This will give you mean square values. So see what is the value?
289.
289.
sir,
सर
wrong.
ये RSS 504 नहीं था सर?
504. Yes,
Yes,
that was 50. This 578 was TSS. You're right.
yes sir.
Unfortunately, I am unable to rub it, so I am going to do this. So this is 504. Okay, this is 504. So 504 divided by 2. What is the
Two,
answer?
252 sir.
252.
252. So 252 is your mean square for treatments. Mean square for treatments. And for mean square for error or mean square error, we also call it mean square error, MSE. So MSE will be 74 divided by its own degree of freedom, that is 9. So see what is the answer.
8.22 sir.
8.22. 8.22. So to find out value of F, what you have to do, you have to write down the larger value as numerator 252, that is MS R. You can say this is MSR or MST, T for treatments and R for regressors. So 252 divided by this value 8.22. So when you will divide in this way, you will have some value, and that will be the calculated value of F. See what is the value. Two five two divided by 8.22.
30.656.
30.656. So you can write it down as 30.66. 30.66. So this is your calculated value. So now you can compare this value with the critical value that you have already found over here, 4.26. So 30 will be to the right side of this value. 30 will be to the right side of this value. It means that will be in the rejection region. That will be in the rejection region. So based on this analysis, you can say as the calculated value of F statistic has exceeded the tabulated value of F statistic, therefore we would reject H naught. Okay, so develop an ANOVA table. We have developed. You will develop the ANOVA table in this way. And what is your decision regarding the null hypothesis? You will say we would reject H naught. We would reject H naught. So this is one way of solving the question. The other way is slightly different, and you can also use that to find out the answer. So let us see the PowerPoint presentation. Now see, as I have already made this for you, so you can see one example from here. So this is one way analysis of variance, the same section that we have just solved an example from this section. One way analysis of variance. Okay, so this is example 16 in your book. The manager of a computer software company wishes to study the number of hours per week senior executives by type of industry spend at their desktop computers. The manager selected a sample of 5 executives from each of 3 industries. At 0.05 significance level, can she conclude there is a difference in the mean number of hours spent per week by industry? Okay. So these are the 3 industries, banking, retail, and insurance. Okay. Data are there. Okay. Same as I have data in this case. You can see there are 3 treatments, and here also there are 3 treatments. Okay. So you can solve this question using 6 steps. Definitely null and alternate hypothesis, where you will write down mu1, or you can write down as banking, retail, and insurance are there. So you can write down this as step 1, null and alternate hypothesis. So H naught, H1. Here you can write down for banking, B is equal to retail. So this And for insurance, you can write down I, or you can write down mu1 is equal to mu2 is equal to mu3. Okay, or here you can write down at least two population means are not equal. Are not equal. Fine, in this way. So that is what I have written over here. The mean number of hours are not equal, or at least two means are not equal, or you can write down all means are not equal. Okay. So in this way, you will set the null and alternate hypothesis. Fine. Then there is some detail. You can understand this detail. What I mean by mu b, what I mean by mu r, what I mean by mu I. Okay. So these are the three industries. Okay, if the null hypothesis is not rejected, we would conclude that there is no difference in the mean number of hours spent at desktop computers in case of all three industries. Okay. If H0 is not rejected, we conclude that there is a difference in at least one pair of means. That is same what I have written over there, that at least two population means are not equal. Okay, then you will write down level of significance, test statistic. This is test statistic, MSB over MSE. So this is there the same, MST you can write down, mean scale for treatments and mean scale error, or mean MS you can also write down MSR, mean scale for regressors, and mean scale for error, or mean scale error. So same as I have done in this case. In this case I have written, if you see this, you can write down here MST, this was MST, and MSE. So MST and MSE could be find out when you will divide the sum of scared value divided by the concerned degree of freedom. So in this case I divided by 2, in this case divided by 9. Okay, so this is same, you can give notation according to your convenience. Then comes decision rule. So how many treatments are there? There are 3 treatments. So K is equal to 3. 3 minus 1, this is degree of freedom, nu1 for numerator. Degree of freedom in case of denominator, n minus k. How many observations are there? There are 15 observations. You can see 1, 2, 3, and 1, 2, 3, 4, 5. 5 multiplied by 3, 15. So 15 are the number of treatments, number of observations, and k is the number of treatments. So 15 minus 3, the answer is 12. So this 12 is for, you can say, the degree of freedom for denominator. Then after writing down this, you will write down this statement. If calculated F statistic would exceed the tabulated value of F statistic, we would reject H0. So how will you find out the critical value or the tabulated value of F? At 5% F 5% level of significance, and at 2 and 12 degrees of freedom, the answer is 3.89. So this value is from the F statistic table. This is the critical value. Fine. Now you have to find out the calculated value, and for calculated value, you can use the strategy that I have used over here. That you find out TSS first. I mean, in this case, if you see, you can use this formula. Write down values one by one and subtract the grand mean from each value, and then find out the grand mean. First of all, grand mean, and then TSS, as I have found in this case. And similarly, you can find out ESS using this strategy that I have done over here. And you can also use this strategy. This is another strategy that may help you in having the same answer. So for this question that I have solved over here, you are suggested to use the other strategy that I shall explain in a while, this strategy, and confirm that whether these answers are same or not. These answers should match. Fine. And for this strategy that I am going to explain in this way in PowerPoint slide, you are suggested to find out the same answers using this strategy. Can you understand what I'm saying?
Yes, sir.
Yes, sir.
Yes,
You
sir.
have to cross check. Use the other strategy to check these answers, and use this strategy to confirm the answer, these answers, okay. And in this case, use this strategy that is there in your book to confirm the answers. Okay, so let me explain this. So in this case, if you see, I have simply written the values over here, 12, 10, 10, 12, 10. These are the values that are there in the question, given table. So these values I have written simply over here. Okay. Then what is there in the braces? The square for these values. When you will take square of 12, the answer is this. Similarly, for all other values, I have taken these squares and I have written those squares in the braces. Right? So you will do in this way. Then there is a column for total. Okay. You will leave it blank. And then you will write down over here summation j xij. This is j. Summation j xij square. This means you are going to add the columns. You are going to add the values that are there in the columns, and the values are in squared. The squared values. I mean 144 plus 64 plus 100. The answer is 308. Okay. So you are going to add the columns. And in columns, the values that are in squared form. So this value 100, 64, 144. So all those values that are there in the braces, you have to add these values and you have to generate this column. Okay. And then there is this column T dot J. So dot is for row and J is for column. So I am putting dot over here because I am considering the rows. So first row, so rows are being changed. First row, column will remain same. T11. T11 will mean the first row and first column. So in the first row and first column, this is the value 12. Okay. In second row, first column T12. So dot will take the value as 2 and J will remain same as 1. Okay. So then dot will take value 3 and then it will take value 4 for fourth row, and then for fifth row it will take value 5. But there is no need of writing down 1, 2, 3, 4, 5. It is understood that dot means rows are being changed and column will remain same. So you simply have to add these values. 12 plus 10 plus 10 plus 12 plus 10. The answer is 54. Simply add these values to have this. But you have to write down T dot J over here. Then add these values, the answer is 40. Add these values, the answer is 42. Okay. And in this total column, you have to add these three values. This plus this plus this, the answer is 136. Okay. And you have to say that this T dot dot is the sum for these values. Or you can say this is the total of observations, the sum for observations. Okay. Then comes the next row, that is T dot J square. So in this case, you can simply square this value, 54 square. The answer is this. 40 square, the answer is this. 42 square, the answer is this. Okay. And then you have to add these three values. You will have 6280 as the grand total. And then finally, the final row is summation I xij square. So here you have to add all these values that are there in the braces, but you have to add the rows. So therefore I have done over here I is for rows and J is for column. So add these values, 144 plus 100 plus 100 plus 144 plus 100. So you will have this answer, 588. Similarly, add these values that are there in the braces. This is the answer. In this case, this is the answer. Now add these values. You will have 1280 as your grand total. And when you will add these five values, you will have 1280. So you have to write down here check. Check means this value should match this value. These two values should equal. Because in this case, you have added the values that are there in the braces and you have written the answers in form of columns. And here you have added the values that are there in the rows and you have added the columns in this case finally to have this value. Okay, so these two values should match. Okay, if these two values are same, it means you are going in the right direction. There is no error in your calculations. Fine. So this is the meaning of check. So in this case, in this strategy, in this method, you have to find out the correction factor. So for correction factor, T dot dot, this is T dot dot, this value. you have to take square of this value and you have to divide it with the total number of observations. So you take, to find out correction factor, take square of this value, 136 square divided by 15. So this is the answer. This is your correction factor. And what is total sum of square? This is the definition for that. T dot dot total for all observations. So this I have already explained. T dot J means total observations in the jth column, no problem. So now the formula to find out the total sum of square, that I have found using this formula, TSS, using this formula. So instead of using this formula, now I am taking help of this formula, xij square minus correction factor. So xij square I have found over here, 1280, write down over here 1280, and subtract correction factor from this. So you will have this. So this is your TSS. Okay. How will you find out BSS? BSS means SST, sum of squares for treatments, or you can also call it RSS, regressor sum of square. Right. So in this case, you have to add T dot J square, all those terms, summation T dot J square. Summation T dot J square is this value, summation T dot J square, this value, 6280. You have already added these values. And finally, this value is summation T dot J square. So T dot J square is 6280, and R means number of rows. So number of rows are 1, 2, 3, 4, 5. 5 rows are there. So simply write down 5, and then when you divide it and subtract this correction factor from this, you will have this value. So you can find out this value, RSS or SST or whatever you call it, BSS, this value using the other strategy. And in that strategy, you will find out this value by subtracting the ESS from TSS. Okay. So in that case, you would have to find out TSS and ESS first. Okay. And then you will subtract ESS from TSS to find out BSS. But here in this case, you can straightforwardly find out BSS, no problem. And then comes ESS. So in this case, if you are interested in finding out ESS, you can subtract BSS from TSS. I mean SST from TSS to find out ESS. Okay, so in that strategy, you first find out ESS and subtract that value from TSS to find out BSS or RSS. And in this case, you can find out BSS and you can subtract that value from TSS to have ESS. So it's upon you. You can use any strategy. But I think this strategy is comparatively easy. Then comes the ANOVA table. And in this case, if you see ANOVA table, source of variation, BSS, ESS, TSS, or you can write down here treatments. Here you can write down error. Here you can write down total. And that is the better way of writing the source of variation. Instead of writing BSS, ESS, you can write down here treatments, and here you can write down error. So degree of freedom, in first case, the treatments are in total 3. So 3 minus 1, 2. And in this case, you can come to this row first, no problem. Total observations are 15. 15 minus 1, this is 14. So 14 minus 2, you can write down 12 in this way, or otherwise write down n minus k. So n is in this case 15 and k is 3. So 15 minus 3 is 12. And remember, n is equal to rk. As rk means, r means rows, and if k means the treatments, so you can multiply 5 multiplied by 3. So in this case, treatments are 3 and rows are 5. So 5 multiplied by 3, the answer is 15. So this is that value, no problem. N is equal to 15 or rk. N is equal to rk, no problem. Then comes sum of square. Sum of square is also denoted by SB square, that I have written first in the previous lecture, where I wrote f is equal to S1 square divided by S2 square. So S1 square you may be considered as SB square, and S2 square that was there in the denominator as SE square. So SB square divided by SE square. Okay. But in that case, we were not considering the degree of freedom, because in case of F, we are interested in writing down MSB and MSE, and these mean square for treatments and mean square error. These two values are obtained when you will divide this value with its own degree of freedom. So dividing this value with this 2, you will have 11.47, and dividing this value with 12, you will have 2. So now out of these two, you can write down this value as numerator and 2 as denominator. So this is the calculated value for f, and you have to compare this value with the critical value, and we have already found the critical value. So 5.74 is greater than this value. It means that it will be in the rejection region. So what will you do? You will reject H naught. So rejection of H naught means you are going to reject this statement. It means if you are going to reject this, it means you are going to accept this. The mean number of hours are not equal, or at least two are not equal. So in the next lecture, I shall explain that how will you see that out of these three, which two are not equal. Out of these three, which two are not equal. So we will make the pair, we will make different pairs, and we will check one by one. Okay, but up till this point, up till now, we have learned that how would we decide regarding the null hypothesis when there are three or more populations are there in the scenario, or in the under consideration. Okay, so this is all for today, and inshallah in next lecture I shall explain this idea in inferences about pairs of treatment means. So we would decide that which pair is not equal basically. So inshallah in the next lecture I shall explain this. So now the time is over, so thank you very much for your patience, and unfortunately we wasted our time initially because of some internet issue, but now it's fine. I don't know who will have the recording, but whoever will have the recording, he is requested to share it in the Google Classroom, so that the other students who are not there at the moment, they may take benefit of this. So thank you very much for your patience. Allah Hafiz. So
Thank you, sir.
I am unable to stop the recording. So whoever is recording, he may stop the recording, and I may take your attendance now.
Mr. Nadeem.
So let me write down your attendance, and then you may leave.
2 मिनट बंद करता हूँ.
Can we leave now, sir?
Okay, I have saved your attendance, and if you have any question, you may ask right now. And if you don't have any question, then we will meet inshallah next week. Have you any question?
वो पहला तरीका easy होता है सर, वो किताब में यूज है या
That
फिर
is
दूसरा
basically easy.